Hello and welcome. Let's talk about the inductive effect today. What is the inductive effect and what really is being induced here? Let's first define this effect and see whether we can answer these questions through the definition. Inductive effect is the shifting of electrons in sigma bond towards the more electronegative atom. It has a shifting of electrons. Now this shifting does not mean the bond is breaking. The electrons are moving only partially. Where are they going? They are moving towards the more electronegative atom. Okay? And which electrons are we talking about? We are talking about electrons in the sigma bond only. No pi bond. Only the sigma bonds. Suppose we have a sigma bond between a carbon atom and a chlorine atom. Each of these atoms will share an electron to form this bond. After this bond is formed, the electrons now are not shared equally. This is because chlorine is more electronegative than carbon. So it will pull the electrons in the bond towards itself. As a result of this, chlorine will develop a partial negative charge. We show that using a delta symbol and we put a minus here. What this means is chlorine has a negative charge, but it's not complete because the bond is not broken. The electrons have only shifted towards chlorine, and so it develops a partial negative charge. Since electrons have moved away from the carbon atom, so it will develop a partial positive charge. Okay, so there is a tug of war going on between the carbon and the chlorine atom, and chlorine is winning because it is more electronegative and it is pulling the electrons towards itself. But it does not want to break the bond. Inductive effect happens because of shifting of electrons in a sigma bond towards the more electronegative atom. Now suppose we have a bond between carbon and nitrogen. Which one of those is more electronegative? Nitrogen, right? So the electrons will move towards nitrogen and they will move away from the carbon atom. So nitrogen will have a partial negative charge and carbon will have a partial positive charge. That is what we are inducing here. Inductive effect is about the induction of partial charge on atoms because of their difference in electronegativity. What are the properties of this inductive effect? The first thing is inductive effect is permanent. It is always present. There is always a tug of war going on between the two atoms. Now if we have a carbon chain like this, C, C, C and then Cl, I am only showing the bonds between carbon and chlorine atoms. The other bonds are there but I have not shown. Now chlorine is going to pull electrons towards itself, because of which it will develop a partial negative charge, and this carbon will develop a partial positive charge. What about the carbon atom at this spot here? What will happen to this carbon? Because the carbon atom to the right of it has a partial positive charge, the electrons in this bond will try to reduce that charge, and so they will also move towards the right. And because of this, our carbon atom will also develop some positive charge. This positive charge will be less than the charge induced in the carbon atom next to chlorine, because the difference in electronegativity is much less here. So we call it delta delta plus. smaller than delta plus. And similarly, the carbon atom next to this carbon will also have some positive charge. I'll call it delta 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 plus, just to show that it is smaller than this charge. So what we are seeing is that this inductive effect travels through the chain and in the same direction. Okay, so it is observed along the chain. And in the same direction. But how far can we go? As you can see that the charge is decreasing as we move away from the first carbon and chlorine bond. So after 4 carbon atoms in the chain, the effect becomes quite weak. So it is negligible. Okay. So we can conclude that inductive effect is a weak effect and its effect is not felt after 4 carbon atoms. It is there, but it is so small that it is negligible. And finally, suppose there is a carbon atom which has 2 chlorine atoms attached. What will happen then? Both of these chlorine atoms will pull electrons towards themselves from this carbon. And so this carbon will become highly electropositive. Okay. So the final thing is, if there are more than one electronegative groups attached, both of them will pull the electrons towards themselves, which is that this effect is additive in nature. Now, what are the types of inductive effect? Well, the groups that are attached to carbon can be either more electropositive or electronegative. Based on that, we classify inductive effect as plus I effect or minus I effect. Plus I effect happens when a group is pushing electrons towards the carbon atom or when it is supplying electrons. For example, if we have a carbocation like this, CH3, CH2 and plus, then the CH3 group here will push electrons towards this carbon atom and so it will show plus I effect. Minus I effect happens when electrons are pulled away from the carbon atom, just like we saw when chlorine atom was pulling it towards itself. So in that case, we show the minus I effect. So if we have Cl and CH2 plus, then this Cl will pull electrons towards itself and therefore it will show minus I effect. Now, since this effect is observed because of difference in electronegativity, what if we have an alkane like CH3, CH3? Both the carbon atoms here have the same electronegativity. So, in alkanes, inductive effect is not observed. All right. Let's take an example. Suppose I have this compound. We have an NO2 group here. We have a CH3 group here. We have a Cl group here and an OH group here. Okay. Now, we have to find out what is the inductive effect of each of these species. Just look at the electronegativity. Now in this compound, OH is more electronegative than the carbon. So it will show minus I effect. Similarly, the chlorine atom over here will also show -I effect. The NO2 will also show -I effect because it is more electronegative than the carbon atom. The methyl group over here, CH3, will show a +I effect because it will push electrons towards the carbon atom. Let's look at this problem. We have a cyclohexane and there is an NO2 group attached here and a methyl group attached here. What is the inductive effect for these groups? NO2 will show a -I effect because it will pull electrons towards itself, and CH3 will show a +I effect because it will push electrons towards the carbon. Interesting, but what if we have structure like this, where there is only a CH3 group attached? What is the I effect here? Is it +I? The answer is there is no inductive effect. Why is that? Why was there a +I effect over here but no inductive effect over here? The reason is the inductive effect at this carbon atom is because of the partial positive charge present at this carbon atom. Because of the partial positive charge here, there is a slight partial positive charge over at this carbon atom, and due to this there is a difference in electronegativity between this carbon and the carbon atom here, and so we can see inductive effect here. But in the compound on the right, there is no partial positive charge on any of the carbons in the ring. So this is a neutral atom, and therefore this carbon has no reason to push electrons towards this carbon atom. So we do not observe any inductive effect here. So when deciding the inductive effect between carbon atoms, be careful if there is a partial positive charge or not. Alright, now let's move towards some applications of inductive effect. The first application is on the stability of alkyl carbocations. We can have CH3+, which is the methyl carbocation, or we can have a carbocation like CH3CH2+, which is ethyl carbocation. Now this is also called a 1-degree carbocation. Why? Because the carbon atom that has the positive charge is 1 degree. It has only one other carbon atom attached to it. Similarly, if we have CH3CH+, this is a 2-degree carbocation, and we also have CH3CH3CH3+. This is a 3-degree carbocation as this carbon is attached to 3 other carbon atoms. How do we decide which carbocation is the most stable? Alright, so there is an important rule when deciding the stability of any species in organic chemistry. Whenever charge decreases, stability increases. In the methyl carbocation, there is no way to decrease this charge. In the ethyl carbocation, we have a CH3 group attached. In the ethyl carbocation, we have a CH3 group attached. This CH3 group will show a +I effect. Because of that, the electrons will be pushed towards the carbon with positive charge, and some of the positive charge will reduce. Since charge decreases, stability increases, so this will be more stable than the methyl carbocation. Okay. Now, let's look at the 2-degree carbocation. It will have a plus I effect from 2 methyl groups, and therefore its charge will reduce even further. Therefore, this will become more stable than the 1-degree carbocation. And with similar logic, the 3-degree carbocation has plus I effect from 3 sides, and therefore it will become even more stable. So the general rule in alkyl carbocations is 3 degree is more stable than 2 degree is more stable than 1 degree is more stable than CH3+, which is the methyl carbocation. Okay, but don't remember this as a rule. Remember that when charge decreases, stability increases. Let's move on to the next application. When we have carbon ions, we have a minus charge on the carbon atom. So this is CH3 minus. Similarly, we can have CH3 CH2 minus. When we can have CH3 CH CH3 minus. This is a 2 degree carbon ion. This one was 1 degree carbon ion. And then finally we can have CH3 CH3 and CH3 minus, which is a 3 degree carbon ion. Now, which one of them is the most stable and which one is the least stable? We can use inductive effect to decide this. For the 1 degree carbon ion, the CH3 group will again show a plus I effect. And what will happen is the negative charge here will increase even more. But what our rule said was when charge decreases, stability increases. So when charge is increasing, the stability will decrease. In this case, the plus I effect of CH3 is increasing the negative charge. So this will become less stable than CH3 minus. Similarly, in the 2 degree carbon ion, there is a plus I effect from 2 methyl groups. So this is increasing the charge even more. And so its stability further decreases. So 2 degree carbon ion is less stable than 1 degree carbon ion. In the 3 degree carbon ion, we have inductive effect from 3 methyl groups. So this charge is increased even more and its stability further decreases. So for the carbon ions, the order of stability is CH3 minus is more stable than 1 degree, is more stable than 2 degree, which is more stable than 3 degree. So the order is reversed in the case of carbon ions. This is how inductive effect works. In the next video, we will look at some problems on inductive effect and further solidify our concept. See you in the next video.